Mini lecture for lesson 104. We're learning about series and, well, you've already learned about sequences, so now we're learning about series. And there's some couple formulas they're going to give you. The arithmetic, so series means that you're adding up the terms in a sequence, basically. So if this is a sequence, then just putting the plus signs in between them makes it automatically turn into a series, okay? So if it's arithmetic, so interesting, if you wanted to find the sum of the first, however many terms, you can take these pairs and they always add up to the same thing. Like, what's 38 plus 11? Let's look right here. 38. I know I should be able to do that in my head. 49, right? 38 plus 11 is 49. 14 plus 35 is 49. 32 plus 17. They all add up to 49, don't they? 20 and 29 add up to 49. And 23 and 26 add up to 49. So that's where you're going to get a formula in a second here that helps you add up these terms. So what you do is you take, there's 10 numbers, right? But the pairs of 49, there's only 5 pairs. We know that these add up to whatever 5 times 49 is, right? Because that makes 49, 49, 49, 49, 49. There's a little formula for that, and it's right here. This says you take half of however many numbers there are, and then you add up the first number and the last number, and you do this little multiplication, and that's for a series, right? A series is when we want to add up the terms in a sequence. It's just called a series. Okay, so if it says S sub 9, that means the sum of the 9 terms of this arithmetic series. Okay, S for sum. As opposed to A sub 9 would be, I just want to know what the 9th term is. But S sub 9 means I want to sum up the 9 terms. Okay, and then 104, the next second part of 104 is geometric. This one's not so obvious, unfortunately. So, yeah, it goes and it says, it becomes a series when you put plus signs in between the terms of the sequence. You'll notice that when you're doing a geometric sequence, you know how you always multiply, like, I'm going to multiply by 2, then I'm going to multiply by 2, then I'm going to multiply by 2. Well, when you're doing that, R keeps going up by a power. Like, if the first number was 1 and then I multiplied it by 2, then I'd have 1 times 2, right? But then if I multiplied that number by 2, I'd have 1 times 2 squared. Get the idea? Because each time I multiply it by another 2, so R is going up, and then these right here are just saying you're getting closer and closer to the end. You're 2 away from the last number. Now you're 1 away from the last number. And then you're, when you get to the last number. Oh, I see. These are the term numbers up here. And these are, and the n minus 1 makes sense because on the first one it doesn't have an R. So, like, you multiply it by R once, twice, 3 times, and it'll end up with n minus 1. And we know, hopefully, that if you look at this, that is the formula that you know for the nth term of a geometric sequence. So anyway, so I have to do one of these proof thingies. Well, I'll do one for you in the problem set. And then the rest of this stuff is just kind of just plugging numbers in and figuring stuff out. So I'll go ahead and do 104. Number 6. Now, if you don't understand how I did it, it's just right here. I didn't copy it exactly down out of here, but it's all right here. Okay, so here's number 6. Develop a formula for the sum of n terms of a geometric series whose first term is a and whose common ratio r. So I start out by saying, well, I'm going to start out with a sub 1, and then on the next term it's going to be that same number but multiplied by, oh, you can't see, but multiplied by r. And the next one it's going to be multiplied by r again, but since I multiplied it by r twice, that's where where these powers of r are coming from. I did mine out to 3 just for fun. I don't think they do that. And then there's a bunch of terms in the middle, and then you start getting close to the end, and you have r to the n minus 1. Okay, and then, so the technique for this is now you're going to take that same exact series, multiply it by r, right, and then you're going to subtract it from the original one, and do like a system of equations, you know, or you know how when you add, like do elimination on it. So, but when I multiply by r, a sub 1 by r, I'm going to start out here. And so, but that's good because these are going to cancel out, right? But at the end, I'm going to have extra 1. I'm going to have that should be down there. Because the n minus 1 got multiplied, that's supposed to be down there. Because the n minus 1 got multiplied by an extra r, it's r to the n. And so all this stuff all cancels out except for this one. And so there it is. And then you can't see that. This came down here. This came down here. Okay, so now I have a sub 1 minus a sub 1 times r to the n. And then this is just, I'm saying I took this and I subtracted this, and there it is. So then I'm going to factor out the s sub n right here. And over here I'm factoring, see how they both have a sub 1 in them, so I factored it out. Then I have 1 minus r to the n. Okay, and then I'm going to, see, I'm just trying to derive this formula that I should have just given it to you. It's right here, I already gave it, or I didn't give it to you yet, but here's the one for the arithmetic sequence series, so you might want to write that down. It's in your book. Here's the one for the geometric. This is, the s sub n means you're finding the sum of however many terms they tell you. Like the sum of the first 18 terms, or the sum of the first 5 terms, or however many terms they say. You're adding all the terms together. Okay, so mine should end up looking like that when I'm done down here. And it does. Right, divide both sides by 1 minus r, and there's my formula. And again, if you forgot how to do that, it's just right on the opposite page. And then go over here, and then it tells me, well, it asked me a question. It asked me, using the formula developed in letter A, find the sum of the first 5 terms. The sum of the first 5 terms, so I stuck a 5 in for, you know, for my ends. Sum of the first 5 terms, whose first term is 2, so I stuck a 2 in for a sub 1, and whose common ratio is -2. So everywhere I saw r, I put the -2, did all the math, blah, 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 and I ended up with 22. So the sum of a sequence like that, a series, would be 22. That's your answer.